We can understand the selective permeability of the plasma membrane by comparing it to a bouncer at a nightclub. Both the bouncer and the plasma membrane are responsible for traffic control. That is, their jobs both involve restricting what can enter and leave and when. A bouncer allows people to enter and leave a club, and likewise, the plasma membrane allows molecules to enter and leave the cell. This is one of your cells, and this is called the plasma membrane. Without it, bad molecules could flood into your cell, wreaking havoc. However, certain molecules, such as water, need to get into the cell. Luckily, the plasma membrane is selectively permeable, meaning it allows some substances to cross into or out of the cell easier than others. The selective permeability of the plasma membrane derives from its structure. The plasma membrane is made up of subunits called phospholipids. A phospholipid is divided into a head and two tails. The head is hydrophilic, meaning it likes water, and the tails are hydrophobic, meaning they are afraid of water. Phospholipids are thus called amphipathic molecules, molecules with hydrophobic and hydrophilic regions. Because they are amphipathic, phospholipids have a special property when put in water. They form a bilayer, that is, two phospholipids' tails facing each other with the heads protruding. This structure is not unlike a sandwich, where the heads are the bread and the tails are the fillings. This structure shields the water-fearing tails from the water. Polarity is key to the selective permeability of the plasma membrane. For a molecule to be polar means that it has regions of partial negative charge and regions of partial positive charge, while nonpolar molecules have an even charge throughout the molecule. To understand polarity, let's look at a water molecule. A water molecule consists of an oxygen atom and two hydrogen atoms. The oxygen atom is covalently bonded to the hydrogen atoms, meaning it shares a pair of electrons with each hydrogen atom. Oxygen is more electronegative than hydrogen, meaning it wants the electrons in the covalent bond more, so it pulls them closer to itself. Since electrons are negatively charged, this results in the oxygen having a partial negative charge and the hydrogens a partial positive charge, making water a polar molecule. Molecules made of atoms with similar electronegativities, like O2, will be nonpolar because they share the electrons equally. Nonpolar molecules, such as O2 and CO2, are hydrophobic, so they can dissolve in the phospholipid bilayer and cross it easily. However, ions and polar molecules are hydrophilic and can't pass through the hydrophobic interior of the membrane, so these molecules need to use specialized proteins to cross. Think of these like the VIP entrances and exits in clubs that only certain molecules can use. So the next time you're turned away at the dance club, instead of punching the bouncer, remember he's just doing his job, like your cell's plasma membranes do, to prevent chaos.